Hello, I welcome you all in this presentation, and in the previous presentation I have talked about the way by which we can define the weldability and we can try to understand the weldability of metals. And what we have seen is like for assessing the weldability of a metal, we need to see that weldability of metal for a given welding process, for a given purpose, and for a given set of the fabrication conditions. These are the one set of the boundary conditions which we can say that a metal A can, with what ease a metal A can be welded by a given process for a given purpose under a given set of the fabrication conditions. But if you have to if we try to understand this definition in more generic way, then for that we need to see that the weldability of the metal, if you have to assess, then we would like to see how much efforts we have to put in for developing a weld joint which can serve the intended function. So, to assess the weldability, how much efforts we have to put in so that a joint can be made which can serve the required function. So, in this connection our efforts will be there to use such kind of the welding procedure which will help us in developing the sound weld joint, like it is free from all cracks, pores, distortion, etc. So, the sound weld joint is made, and it is not just free from the defects, but also it is technologically sound, which means the weld metal properties and the heat affected zone properties are such that the joint will perform for long and it will not lose its performance during the service. So, how to quantify the efforts? For that we need to see the various aspects related with the welding procedures. Welding procedure means what are the different welding procedural steps which are needed so that a joint can be made which is free from the defect and technologically sound, so that it can perform the intended function during the service for a given life, which includes right from the cleaning. There are various methods of cleaning like simple mechanical cleaning or mechanical plus chemical cleaning. Which method of the cleaning will be used so that it is free from the inclusions and the defects, free from the oil and grease, and during the welding it does not impose any problem. Similarly, use of chemicals for, so chemical or mechanical cleaning. We have to remember that more the efforts, more the steps are needed for completing a given step of the welding procedure, lower will be the weldability, because we need to use more resources, more time for completing that particular step. So, obviously, if the welding of a given metal needs just mechanical cleaning, it will be of the better from the weldability point of view as compared to the metal system which needs both chemical plus mechanical cleaning. Now, edge preparation. Second step is edge preparation. There are many metals which offer so good weldability that even simple square groove geometry can be used. It does not require any edge preparation, but there are many metals in order to achieve the required depth of penetration, required fusion through the thickness of the plate, the preparation of the edges in form of the V groove, U groove or the J groove geometries is required. So, whenever edge preparation is performed, it requires the steps in form of machining. So, for edge preparation we need to perform it may be like the flame cutting, or it may be mechanical machining. So, flame cutting is not considered to be good for those metals which are hardenable, because it forms a very hard and brittle structure on the cut edge which is produced by the flame cutting. Mechanical machining is considered to be good for the edge preparation. Like flame cutting can be used for the V groove preparation, but if the metal is hardenable it will lower down the weldability. Simple mechanical machining is better from the edge preparation point of view, but the process is slow. So, it will take longer time and that will be poor from the productivity point of view, and something which is taking longer time, more efforts for completing one step like edge preparation or cleaning, it will lower down the ease of welding or the weldability. So, which type of the edge preparation is needed, which method of the edge preparation will be used, like flame or the mechanical machining, that will also determine the ease of welding. So, after the two steps like cleaning, mechanical or chemical cleaning, edge preparation, flame cutting or the mechanical machining, or the given groove geometry, like no edge preparation required for a square groove geometry as compared to the case when significant machining is needed for the V and the U or the J or the bevel groove geometries. So, more the efforts are required, lower will be the weldability. Then next, after the edge preparation, as per the metal system we may require preheat of the different magnitude, different temperatures. For example, preheating is performed for the different functions, for different purposes, like to lower down the residual stresses, to lower down the distortion tendency, to increase the depth of penetration, to reduce the embrittlement due to the hardening tendency of the given metal. So, the metals which require no preheat will from the preheat point of view will be considered to be more weldable as compared to the metal systems which for producing the sound weld joint, which can perform the required intended function for longer life. If preheat is needed, it will be lowering down the weldability. So, weldability will be reduced if we require preheat. Now, another thing, like if limited preheat is to be used, the preheat may vary like say 50 degrees centigrade to 300 degrees centigrade in case of the steels. So, lower is the amount of the preheat needed, easier will be the weldability or the better will be the weldability as compared to the cases where higher degree of the preheating temperature is needed, because it will be more difficult to work with the preheated plates, preheated metal systems. So, the weldability will be poor. So, no preheat is the best possible situation from the weldability point of view, and if the preheat is to be used, then preheat should be as less as possible for the better weldability. Higher the preheat requirement, lower will be the weldability of the given metal. Then we have the process. We know that there is a range of the welding processes which can be used. A metal can be welded using a different types of the processes, but like if one which can be welded easily with the SMAW process, which is very easy to apply, low cost, does not require much skill, and expertise. It will offer the low cost and easy to apply. So, it will offer the better weldability as compared to the case if it require the laser welding or the electron beam welding. These are very specialized processes, advanced processes. So, this requires the vacuum and a lot of initial investments. So, the cost is high, the equipment very high expertise is needed. So, more the efforts in terms of the advanced process used for development of the weld joint, lower will be the weldability as compared to the case when the simpler processes like SMAW process or the gas tungsten arc welding process or the gas metal arc welding process, if these can be used, then the weldability will be better. So, if joining or the welding of metal needs a simpler process which is easily available, can be applied easily for development of the weld joint, then it will be considered as a better weldable or of the good weldability as compared to the other metals which require the advanced processes like the laser welding and the electron beam welding. So, if we compare if the requirement for the welding process is like this SMA, GTA, GMA, then plasma arc, laser and electron beam. So, you can say the in order of the decreasing weldability, if the metals needing the advanced processes, then the weldability will be considered to be reducing. It will be easier to apply, low cost, very flexible SMAW process will be considered of the higher weldability as compared to the laser and the electron beam welding. Likewise, if we see the post weld treatment requirement, suppose we have made by after proper cleaning, after proper edge preparation, preheating of the base metal, we have developed a sound weld joint. But in order to impart the required technological properties, it may be required to perform the post weld heat treatment, like for lowering down the residual stresses and distortion tendency, for improving the microstructure and mechanical properties. So, if we have to perform the post weld heat treatment, this will be the another step which will be needed. So, those weld joints which do not require any post weld heat treatment will certainly be considered of the better weldability as compared to the metal systems which requires the post weld heat treatment. Likewise, in order to reduce the residual stress and distortion tendency, post weld treatments in terms of the shot peening may help in lowering down the residual stresses and distortion tendency and improving the fatigue resistance. So, for improved performance of the weld joint, if you have to perform the steps like post weld heat treatment, shot peening or any other treatment which is required for developing the joint which can perform the required function, then we need then that will be reducing the ease of welding. The another point is the precaution, like for developing the weld joint of the given metal, if we require more precautions in terms of the radiations or in terms of the preheat or the post weld heat treatment, for developing the joint which is having the required mechanical and metallurgical properties so that it can perform the required function during the service, then certainly it will be reducing the ease of the welding. Now, so the efforts required for welding of a given metal will be an important aspect in determining the weldability, which we can see in respect of the edge preparation, cleaning, preheat process, post weld heat treatment and the precautions required. We have also to see for assessing the weldability of metal, like what kind of the quality of the weld joint is produced. Quality is very generic word. So, to assess the quality of the weld, we would like to see what kind of the uniformity in mechanical and metallurgical properties exist in when a weld joint is developed. For required performance during the service, it is important that across the weld joint from one side of the base metal to the another side, it is by and large having the uniform microstructure and mechanical properties, in which normally we measure using the hardness. So, if the microstructure from the base metal to the heat affected zone to the weld metal and again heat affected zone to the base metal, if everywhere the microstructure and mechanical property is same, then we will consider that the quality of the joint is good. Another way to assess the quality of the joint is the soundness, whether it is having the required weld bead geometry or it is free from the discontinuities. Whenever we make any weld joint, the weld joints invariably contains the discontinuities. These may be fine, these may be acceptable. So, if we make a weld joint, there will always be discontinuities in form of pores or inclusions which may be extremely fine, like 2 to 5 micrometer, but these discontinuities may be acceptable. So, those welding process which either develop the weld joints which are free from such kind of the discontinuities, or discontinuities are negligible or they are very fine in size to have any adverse effect on the performance of the weld joint, then those weld joints will be considered to be of the better quality as compared to the other weld joints where there are issues related with the weld bead geometry and the large discontinuities in the weld joints are present. So, efforts to a great extent will be determining the quality of the weld joints as well as the cost which is involved. Cost is very important in making decision about whether a metal should be welded by a given process using given set of the conditions or not, because more the steps are involved in development of the weld joints, greater will be the cost. Simple mechanical cleaning, no edge preparation, simple SMAW process, sealed metal arc welding process is used, no post weld treatment required. Probably this will be leading to the minimum possible cost of the weld joint, but all the metals do not offer such kind of the luxury. We may require the mechanical plus chemical cleaning, we may require very precise edge preparation using like J or the U group geometries, we may require laser welding or the gas tungsten arc welding processes, we may require a number of post weld heat treatments, so that the required set of the technological properties required in joints can be achieved, so that it can really perform the required function during the service. So, greater the number of steps required for developing a joint with the required set of the properties which can perform the intended function, greater will be the cost, and which in turn will be reducing the weldability of the metals. So, lower is the cost of welding of a given metal with the required set of properties which can perform, higher will be the weldability. Now, we will be talking about the different aspects related with the metals which will be affecting the weldability. So, there are various properties associated with the metals that affect the weldability. These are like say the physical properties, then metallurgical properties, chemical properties, strengthening mechanism and mechanical properties. One by one I will be explaining all these points. So, among the physical properties, the points which are important like thermal conductivity, melting point, boiling point, thermal expansion coefficient and electrical conductivity like resistance. So, these are the physical properties which will be playing a big role in determining the ease of welding of the metal. Like in the fusion welding process, when we apply heat near the fixed surfaces in order to facilitate the fusion of the fixed surfaces, so that metallurgical continuity can be achieved. So, the application of the heat to facilitate the fusion, when this heat is applied, a part of the heat is used for melting the fixed surfaces, but a part of the heat due to the thermal conductivity of the metal is transported to the underlying base metal, which in turn leads to the development of the heat affected zone. So, greater is the thermal conductivity of the metal, greater will be the amount of heat required to facilitate the fusion, and this will be leading to the greater heat affected zone. So, it will be considered to be undesirable from the welding point of view. So, those metals which have the lower thermal conductivity, they are able to transfer the heat to the underlying base metal in very limited quantity, and that is why most of the heat which is applied is used for facilitating the fusion. This will be reducing the weld zone size, this will be reducing the amount of heat to be applied, and at the same time this will also be reducing the size of the heat affected zone which will be formed. So, in general, higher is the thermal conductivity, lower will be the weldability, because we require more amount of the heat which produces the larger heat affected zone as compared to the case when the low thermal conductivity metals are used. So, low thermal conductivity metals like simple mild steel or the austenitic stainless steel. So, if we compare the mild steel with the austenitic stainless steel, probably from the thermal conductivity point of view, ASS will be offering us much better weldability as compared to the mild steel, because ASS has the lower thermal conductivity due to the higher concentration of the alloying elements. Then the melting point, certainly in case of the fusion based welding processes, we have to fuse the fixed surfaces of the base metal. So, if the melting point of the metal to be welded is high, then it will be difficult to melt, like metals like tungsten, titanium, these which are having the higher melting point, they will require more heat, and the energy density associated with the many welding processes may not be sufficient to bring the fixed surfaces to the molten state. So, the weldability will be poor. We may require more advanced processes to ensure the fusion of the fixed surfaces, those high temperature metals. But it does not mean that those metals having the low melting point will always be showing very good weldability, because there are other points which will be determining the ease of welding. So, a reasonable level of the melting point certainly will be offering the good weldability. So, melting point determines the ease of the fusion, and so low melting point metals in general offers the good weldability as compared to that of the high melting point metals. Boiling point is the another important physical property that affects the ease of welding. Say those metals having the low boiling point metals like zinc, magnesium, during the welding, like say using arc welding or using laser or using the electron beam, the high temperature generated during the welding leads to the evaporation of such kind of the metals which are present in the like say steel or in the aluminum alloys. So, the metals which are being welded using either arc or the any other heat source, if it is having, if those metals are having the low boiling point metals as alloying element, during the welding these will evaporate, and the evaporation will be leading to the loss of those alloying elements from the weld metal, and loss of alloying elements of the from the weld metal will be leading to the change in the microstructure, change in the mechanical properties which we might have not anticipated. So, if the boiling point is high, then chances for the evaporation will be very limited during the welding, and they will not be losing those elements during the welding. So, the properties and the structures will remain intact even after the fusion welding. Next is the thermal expansion coefficient. We know that during the welding basically the heat is applied in very localized manner. This is the line of this is the weld line, and heat is applied through the suitable heat source. So, this is the only zone which is being heated, which is being brought to the molten state, and there will be a zone next to the molten state which will be heated to the high temperature. So, the metal in vicinity of the weld zone which will be heated to the high temperature will be experiencing the thermal expansion during the welding, and once the heat source has passed, due to the loss of heat, reduction in temperature, it will be subjected to the thermal contraction. So, localized, basically the problem is the localized expansion and contraction leads to the development of the residual stresses, and in general in the weld joint as and the heat affected zone we get the tensile residual stresses, which tends to distort the weld joint or the plates being welded. If the rigidity is limited, especially in case of the thin sheets, the residual stresses leads to the distortion, and also especially the tensile residual stresses reduces the load carrying capacity and the fatigue resistance. So, all those metals which offer the higher thermal expansion coefficient during the welding, they will be showing the greater residual stresses, greater distortion tendency, reduced fatigue resistance as compared to the metals which offer the lower thermal expansion, because the magnitude of the thermal expansion and contraction due to the weld thermal cycle experienced during the welding, that will be limited in case of the low thermal expansion metal systems as compared to that of the high thermal expansion coefficient metal systems. So, for example, mild steel, if we compare mild steel and austenitic stainless steel, ASS offers the higher thermal expansion coefficient as compared to the mild steel. So, there are more issues related with the residual stress and distortion as compared to the mild steel. In case of the the welding of these two metal systems by the fusion welding process. The next point under the physical properties category is the electrical properties. Among the electrical properties, basically it is the electrical conductivity or the resistance. So, this electrical conductivity is important from the resistance welding point of view. where primarily I square R T heating principle is used for development of the heat, like in spot welding, seam welding, projection welding. The high contact resistance at the interface of the components to be joined is used for developing the heat through the application of the current I for a certain time. So, the contact resistance R at the interface determines the magnitude of the heat being generated. So, if the electrical conductivity is high, the contact resistance will be less and it will be generating the limited heat. So, the high electrical conductivity metals will require more current for generating the sufficient heat, so that the joint can be developed as compared to the metals which are having the lower electrical conductivity. So, it is always good from the electrical means resistance welding point of view that the metal is having the higher electrical resistance or the lower electrical conductivity. For example, the welding of the steel through the resistance welding process will be easier as compared to that of the aluminum and the copper welding, because both these metals offer the higher electrical conductivity, lower electrical resistance. So, we require very high current for generating the sufficient of heat, so that the joint can be developed. So, now here I will summarize this presentation. In this presentation I have tried to talk about the way by which we can assess the weldability using the factors like efforts which are required for developing the weld joint, the quality of the weld which is made, and the kind of the cost associated factors. And I have also talked about how the physical properties of the metal can affect the ease of welding. Thank you for your attention.